and welcome to our talk on UI automation with XCUITest.
Hi, I'm Poornima, and I'm working as a senior software engineer with Sky Betting and Gaming. So I've been working here for like 4 years now. So when I started, we were working with doing UI automation with Appium for both iOS and Android. But we've since then switched to XCUITest, and we work with automating the iOS application now.
I'm Sanaa Shazadi. I'm an iOS developer and formerly a software engineer in test, where I worked alongside Poornima.
Before we go into XCUITest and how the app UI automation is structured there, we'll briefly touch on UI testing and unit testing. So UI testing is your usual like system, functional, or acceptance testing. And this is when you test the whole system together. So where you're performing like end-to-end journeys as a normal customer would do. So this is a black box testing where you do not have much idea about what's inside the code base. But a unit testing is the test that's generally written by developers within the code base. So it's usually small portions of code to test your modules or individual classes and methods. And this is generally in isolation with the rest of the projects. And it's a white box testing, which means you are aware of the entire structure of the code base. And it's usually good to have a good balance of both unit testing and UI testing in your projects.
So to demonstrate how to set up UI automation testing, we have a little project called Automation Animals. We'd like to give a shout out to Matthew Glover for providing his app for us. We now have a little video to show you how the app works. So we have this initial landing screen. We call it Animal Gallery. We can write tests for this to check all of the animals appear and they appear in the correct order. We can have user journeys to select an animal, check if the button and the correct text are shown. We can then check on the filtered animals. When you select it, we can remove them on the favorites. And then once you've returned to the screen, you can go to the filter in the top corner. You can select a particular filter such as ice, and in this case, it filters out each of the animals. We can also select clear all and then return to the animal gallery screen.
Yeah, so how do we start setting up the UI test automation framework? So initially to create the UI test case class, you need to create a new file like how you would normally create any Swift files. And once you select a new file, you can select a UI test case class, which will bring up a template like you can see on the screen. So this would import the XCTest library, which has all the functions that's required for your XCUITest functions. And this has a superclass as XCTest case. And there would be a normal template which has a setup, teardown, and your test modules. So the test would generally be written as a test method with the keyword test in the beginning. And before and after each test is run, it will execute the setup and teardown. So in order to run the test that you set up with the UI test case class, you need to set up a test scheme. So if you look at the big top corner of your Xcode, you can select a test scheme. So if you click on there, and then if you say new test scheme, you can select your target as your UI automation target, and you can give any name that you want to. So once you've created the test scheme, you can go and edit the test scheme to point to any of the tests that you want. So by default, you can select all the tests in your UI automation test pack. Then when you run it, you can select or deselect the test based upon what you want to run at any given point of time. You can also select a test plan. So we'll be talking about test plans in detail later. But you can also select it to just refer to a test plan rather than selecting individual tests. And you can also give other options like any launch arguments that you want to pass, any environment variables that you need to set during execution of the test. And also you can set up the location of the simulator. So your app starts in the simulator with the location that you've specified in the test scheme as well.
So next we're ready to set up our folder structure. The way we recommend to do it is having a base folder. This is where we include our base class. This works as a superclass and contains any methods that are shared across the various tests. We then have a test folder. These are all individual tests separated by all of the screens on your app, and these are all written in a BDD format to improve readability. We then have steps. This is where all of your actual methods are contained, and the elements contain all of the components that you will be testing. In test plan, we can group these by individual test plans, such as all tests, or you can group these by screen or priority. So the test file works as a wrapper around all of the methods. It's written in a BDD format, so given a particular scenario occurs, this is the precondition. When I do something, so an action is performed, then I see the result, and this is the verification. We use the BDD format to encourage testing complete user journeys. So in this example, we have given automation animals app is open. When I am on the animal gallery screen, then I can see the animal gallery title and filter and favorite items. This is to encourage members of your team that might be non-technical to take part in running the test. They can manage the tests and execute them, and at a glance, they can see what each of the tests is doing. Next, we have the steps file. This is where all of the methods are contained. Any verification or any actions that need to be performed are done here. We also have something called XCUITest. Here you can add a tagline, which can be as verbose or as simple as you'd like. It's generally there to improve the readability of your tests, and it means that when you do execute your test and you see the end report, you can see the actual text that you've put in here rather than the method name. You can also have different gestures take place within the steps file. So this can be tap gestures, swipe, or assertions. So you can assert if a screen has loaded or an element has loaded. We generally use this with XCT async assert, but we also have other options such as assert true, assert not nil, and assert equal.
So we saw how the methods are structured and how we've got like actions and the verifications on the elements in the previous slide. So all these elements that we use, it will be a better idea to just separate them from the code base and have them in an individual place so that we can go and edit them, because otherwise if it's hard-coded inside the code, you'd have to go and edit the identifiers or labels each time it changes. So we've got like a folder called elements for that, and here we have different files which we have grouped based upon the, you can group them based upon the functionality or screen or pages or any kind of grouping that you want to do. So inside each file we've got different enum, so we've structured each screen as an enum. And here you can see the turtle passport screen. So this is the individual screen that comes up with the turtle's image and the properties and name that you saw in the demo app. So we have an enum called the turtle passport screen, and then we have various elements that we are interacting with there as different cases. So we can have different variables associated with each case. So we've got a variable called element, which returns the variable in itself, the element in itself. So you can have different types of element inside an enum. So you can have images, static text, navigation bars, anything that's present, it would return back with the variable element from the enum. You can all have different properties like your label, any value that you want to check with each element also inside the enum that we have here. And we also tend to use some IEEE cases within the enum. So here you can see that we have defined like a enum with as case IEEE. So if we want to perform certain tests or certain lines of code repeatedly on multiple elements, we can define these as a case IEEE enum, and then you do not have to repeat the test, or you do not have to repeat a different method for this. So you can see that this is used in this test that we have here. So we are using like a for loop to iterate through all cases of the animal gallery enum. So the test that's mentioned here would repeat each time on each of the case that's present inside the enum. So you can see that when I tap on this animal, then the animal detail screen is displayed, and I can tap return to return back to the animal gallery. And you can see that in the result as well, it will be coming as separate tests, so you will know exactly which test is failed, like which animal case is failed in case of any failure that you have. And in addition to having fixed identifiers and labels to identify the elements, we also use containing. So we have a format which has contains. So you're checking for the in string of the identifier rather than the entire text. So in cases where there are dynamic properties, or say when there is any property which gets attached to the name of the identifier during runtime, it helps with identification because we are only referring to the in string rather than the entire identifier in itself. Right? So in the folder structure earlier, we saw that we had like a base class. So this is nothing but like a super class we are using across all the test files that we've got. So we have separated out the setup and teardown that we are using across the UI test framework inside the base class. So unless we need to do any specific setup or precondition for a particular test case file, all the other steps are done here. So we've just got like launch because that's the only thing that we are doing before starting the test. So we've separated out the launch here, and any teardown that you need to do, so any kind of cleanup that you need to do after each test, also you can do it in this base class file. And we've also got any common functionalities that we generally use across the elements. So we have things like the XCT async assert, which Sanaa was mentioning that we used in the steps file, or like wait until element is present. So such common functionalities across any of the tests we have defined here. So it basically acts like a repository or a library of all the methods here. And in case you want to use like mock data, you don't want to rely on actual data during your runtime, you can also use mock data where you can stub like override any URLs or API responses and use your own data, which you can provide in a JSON or an XML format, or however you want to give it as well.
So once you have your test steps and elements file ready, you're at a good stage to create a test plan. Xcode does provide a template, so you'd simply click new file, choose the test plan template, and then choose your target, which in this case is Automation Animals UI test. This will return a screen that looks similar to this. These are all of the tests that we've just written. These are separated by each test file, so we'd have animal passports, you could have favorites, or the filter screen. Within a test plan, you can activate all of the tests, you can activate all of the tests within a test file, or you can pick and choose whichever ones you would like. At this point, you can also change the location of your test. So each test plan can have a different location set by default. Once you have a test plan, you can then add this to your test scheme. So you would select the little plus icon, you can choose an existing test plan or create a brand new one, and each test scheme can have multiple test plans attached to it. At this point, you can also choose a default. So every time a particular test scheme is run, you could have a default test plan that runs with it. And finally, you're at a good stage to start running these tests. In order to do that, the command to use is command new, and that will start executing all of your tests in that scheme.
So like how we have just kicked off the test in the test scheme earlier, once you've done that, you can see the live status of each test in this particular icon here. So it's called as the test navigator, I think. Yeah, it's called the test navigator. So this is the little diamond with the tick button. So once you click on that, you can see like a live status of all the tests that's been run. Anything that's passed will be shown with a green tick, and anything that's failed will be like a red cross. If you've got like test in running, it will be shown with a spinning icon next to it. So once the tests have finished running, you can move to this last icon here on your tab, and this will bring up the test results that you see here. So it will have sections, different tabs based on all the tests that's run, separate sections for how many is passed, how many is failed, skipped, or any expected failures that you have. So we have these tests that's passed, and then you can see how the advantage of using the verbose detailed reporting with XCT context that Sanaa was talking about earlier comes into picture. So we can see that it says, like, given the automation animals apps open, when I tap the filter button, then I can see the clear all and done button in the filter bottom sheet. So it gives like a clear, step-by-step explanation of the BDD test that's been carried out in that particular automation test. And in case a particular steps failed, we would have a snapshot attached to it. So on case of all the past test cases, there wouldn't be anything additionally attached to it, but if there has been a failure, there'll be a snapshot, so which you can see as the automatic screenshot here. So once you click on it, you will get a screenshot of the mobile device at that point of time, and then it's easier to debug whether it was an actual failure or if it was just, like a random connection issue or the app failed to load and things like that. So debugging as well. So during a test run, you can always debug your test by adding breakpoints. So you can do so by just clicking on the line number, and there's this blue image that comes up with a breakpoint. So during execution, once it gets to that breakpoint, it'll pause, and you can use the bottom debug window to do any debugging. So if you want to just get the entire element subtree to find out the order of elements or the properties of the elements, you can just do a PO of XCUI application. This will print the entire element subtree, and you can determine the properties of each of the elements from here. And while you have this as well, it's easy to do like individual steps that you want to test. Like, say you want to just tap on the filter button just to see how the filter button, if you just want to include that step in your test, you can just try it out here before you actually put it in the test. So you can just say a PO XCUI application dot button of favorite dot click dot tap, and it would do the tap in runtime. So this helps with adding more steps to your test as well. Then you can add it, so you don't have to rerun and rebuild the whole application here. Okay, we have a little demo of the execution. We didn't want to do a live demo, so we've just taken a recorded video. So like we mentioned before, we can select the test scheme here and also select the device that you want to run on. So we've selected iPhone 11. So currently the video that we've got, we are only running on one simulator, but you can also do a parallel execution. So if we've given, like, in the test plan that we showed earlier, there is an option to check a button called execute in parallel. So it will bring up various clones of the simulator that you've selected. And so there's the number of tests that's there in the list would be like divided amongst all the clones. So your entire execution takes lesser amount of time, and it'll be available sooner. The results will be available sooner. So you can start with that. And we have the, so we've got given all the tests that's running here. So it's selecting the all test plan, which was the default test plan in the test scheme that's selected. So it's currently kicked off, and then you can see that once you go to this test navigator, the test that's passed is shown with the green tick, and we've got the running ones with the spinning icon. So this one's favoriting the elephant, and at any given point of time, you can click on this button here, which is like a cross button, to see if there's any failures at that point of time, and then it's easier to find out if anything's failed even before waiting for the whole execution to get over. So during the test run, you can also see the log in the below bottom console here. So if you're just interested to see why has this test not finished, or what's happening at that point of time, you can just go here and then it'll give you a better idea of what's happening. So just like checking existence of favorite button. So just better to understand what's just happened at that point of time. And we are also running this test now, which is test the animals in the animal gallery, which actually uses the case iterable that we were mentioning before. So you'll have the animal gallery here, and this test actually like goes into each of the animal pages one by one and checks for the properties and returns back. So it's just doing it one after the other on each of the animals. Yeah, and this is where it's being used. So this is for animal in the animal gallery dot all cases. So just iterating through each of those animals there. So where we've got this enum. So in case we had given the parallel execution, it would be like executing multiple tests together on different clones, and then it will be just like quicker, so you'd be able to find the result faster on that. We initially had plans to add our pictures as animals, but then we didn't think it was appropriate, so we just stopped doing that. Yeah, so it's almost coming to the end of this test. You can see that the properties has been added. So we've given like launching the application before each of the tests. So it just like does a fresh launch and then does the test and then terminates the application. So before each test, it does a fresh launch and kills the application after the test is finished. So we have also given an expected failure in this test that we have here. So that is why, so you can see that instead of the red failed button, you actually have a gray fail button. So which means that in certain tests that we know that there's a existing bug or you're expecting the test to fail because of some known issues. So you'd give like a keyword called XCT expect failure, and then you can just give what is it, like if there's a bug ticket, you can give the bug ticket number or why you're expecting that test to fail. So we've just given like an intentional failure here. So instead of it looking for like 13 properties, we've just given it as 10 to just demonstrate this keyword. So if that's given, it'll just show fail with a gray cross icon. So it will not be treated as an actual failure, but it will not come in the past ones as well. So you will always be aware that there is some, it's kind of like a to-do, or that there is work that's pending in this particular test and you'd have to look at this later. So this test, once it completes, you will get like a test succeeded or a test fail message depending on the result that you have. So because there was only an expected failure at this time, we got a test succeeded button. So once that's done, you can go to the last icon there to get the test results. So we have by group or by time. So in by group, it will be grouped according to the test plans that's available, and by time will just be like a chronological order of how it's happened. So we are just going to select the by time and select the last test. So once you select the last test, you can see that all the tests that's run is available there, and the reporting, like how we've given in the XC context, is also provided there. So we do not have any snapshots for the past ones, but the expected failure wouldn't come in the fail section, but it would come in the separate tab with expected failure. So you can see that we are expecting 13 as a properties count, but since we've given it as 10, it's failed. Oops, started the video again, I think. No. Okay. Yeah, at the right place. So we've come, yeah, this is the expected failure. So we are looking for filter property count as 13, but we've just given it as 10, so it's failed. So you can see the snapshot at that point which lists the properties, so you can, when you look at it, you know that it's not an actual bug and it's failed due to some other reason. In this case, it's because the value we passed was not the one that was expected. That's the end of the demo video.
So in conclusion, we have a couple of pros and cons for using XCUITest. XCUITest is limited to iOS devices only. There are products out there, such as Appium, which do allow cross-platform testing. It also means you're limited to using only Swift. However, that means that developers can contribute to writing your test code. It results in a more collaborative teams, and everyone can take part and take ownership of those tests. It also means writing tests is a lot easier since the development code is in the same repository. You can add identifiers or properties since you have access to development code. And a big bonus is that there's no additional components required. As long as you have Xcode, you're kind of good to go and start writing your own UI automation tests. So thank you everyone for attending our talk. We hope you learned something new or found something interesting.
And if you are interested in looking at the repository we've created, you can scan this code. It's available on GitHub.
And yeah, if you have any questions.
All right. That's awesome. It was really good. Really, really good. And first-time speakers on stage. Amazing. Really awesome. Really awesome. So, we've got some questions that have come in. The top one is, why did you stop using Appium and any drawbacks?
Yes, so when we were using Appium, we had like a lot of dependency managements in place. So because it's an open source tool and it was using other libraries, we had to keep chasing each of the dependency versions that's coming up. And for support as well, it was tougher. And another thing was that because we have the development going in a Swift code base and we're writing Appium in like a different library. So it's completely a different repository. So there was very minimal interaction between the devs and the testers. So the kind of collaboration we had was also less. So it was always important to have more collaboration and have the support and work as one team going forward. So a lot more easier now.
Getting developers to write tests. Yeah, excellent. How do you optimize? Yeah, this is something I was thinking about, because I don't know about you, but when I run UI tests, I basically have to leave the Mac for like a period of time, make a coffee, and it's like, oh, it failed. So how do you optimize the test, in terms of speed to run as fast as possible?
Okay, yeah. One thing like we mentioned is the parallel execution. So you can always do a parallel execution there, and also like rely on like CI systems and pipelines where you can like divide your execution across multiple simulators, and then you can always optimize things like launching the application, exiting the application, etc., depending upon how your tests are. So you don't need to do it every time for every test. You can make common functions separate, so you're not repeating, say, things that you don't need again and again for each test.
Just touching on that as well, you could have test plans that are separated by priority. So you could have your goal tests in a separate scheme, and then you're only running them every time you've made a change. So you can make sure all of your key functionality is working. You're not necessarily running the entire suite. But like Poornima said, if you have a CI pipeline, you could have it to run all of your tests overnight. And then during the day, if you've added more code in, you can just run those goal tests and make sure everything is working.
Nice, really cool. Anyone in the audience whilst I'm using Slido? Yeah.
I've possibly misunderstood, because that's probably what I've done. But in the bit where you're trying to find elements, and you're finding your text elements using strings, are they meant to match the copy that's on screen? Or are those IDs?
You can do both. So you can match depending on the actual string value, or you could set up an identifier and you can also search by them. So you get the option to do both, whichever one you find easily.
If you're matching copy, how would that work if you're testing localizations?
What was that, sorry?
If you're matching to copy on the screen to find the element, how would that... Sorry, I think it's because I'm close to these. How would that work if you're then testing localizations and you want to test multiple languages on the screen?
That's a good question.
I didn't get the question, I'm sorry.
I don't know how else to phrase it.
So like if you've got an app that's multiple languages.
Yeah, so with multiple languages.
How would you test multiple languages?
Yeah, we've currently not handled that at the moment, so probably something for later.
I guess you could put different string elements.
Maybe we can do this.
Everyone does it, so you can do it.
Okay. Maybe one to explore.
Yeah.
Yeah. Okay, we've got 1 minute. Have you ever written test cases for apps with camera scanning? It's jumped. I.e. a barcode functionality, and how did you manage it?
No, I've never written.
No.
No, I've not tried that.
No. I mean, we've got an app.
Maybe.
Click, that we could maybe test it. Okay, we'll do one more. If the app you are writing UI test for has to perform network calls, which then updates the UI, what's your preferred way to handle this? So network calls to pull data, I think.
So you could set up mock data, so you're not relying on doing actual network calls. It's something that you can use along with the base class. So every test file or step file at the top, you could have your setup in the base file, or you could have it per test file. So you could say all of the tests for the passport screen, for example, will rely on this mock data. So you're not making actual network calls when you're running the tests.
Which would make them more stable, I guess.
Yeah.
Yeah.